G'day guys, and welcome to what I'm going to show you. What I did is this one here is my old mount, and this is my new redesigned mount now that my 3D printed model did not match. So stay tuned and I'll show you how I achieved turning this model into this one. Okay, so we're now into the app, into the design space. So I've created a new part down here at the bottom of my tree called Revised Mount. Now, I first started off with doing a sketch. So from that sketch, I'll open him up. My apologies if this takes a moment. So what I've done is I've got my body 45, which was my original sketch, and it was in the background there. And what I did was I took from him and superimposed, using the project function, my K-frame mounting holes in the right spot. Now what I also did was I took my points, which were here, and they were 1 inch apart, and they were 16mm. And essentially what I did was measurements from the current setup is I need to go 50mm forward and 80mm towards the driver's side. So all I did here was I just went 50, 80, and that should put my little right there. Now I then decided, okay, so from here, I want my center, which should be 1 inch, to here, which, as you can see, that gives me my datum right there. And what I did was I just drew a slot. It's 16mm wide, and it's just big enough to fit my bolts through. So I will just delete all that because that could screw up my thing. And what I did from there was I created the sheet metal component. So up here at the top you get your sheet metal tab, and you just hit your flange button with your sketch on and it creates this. You've got to select all your faces and you're off. There is a lot more better videos on YouTube to show you this than what I can do. Now from here I've got a fairly boxy one. These hard corners can form cracks, so I don't want. So I started off by rounding some corners. So I rounded these corners first and went, okay, cool, because I've got to be cognizant that I have a radiator mount right about here. So I couldn't put too much of a sweep on that bend. I rounded the front just to make that nice and pretty. Then I rounded both the ends there. So that just makes it look a bit neater and cuts down on. So, and yeah, and then the other thing I did is I thought, well, I don't want to get it too tight. I only really get one shot at this and I can't really carve that out bigger. So I just drew a sketch on here, and can I bring that sketch up? Wrong button. No, don't show me the bodies. Sketches. And that would be my sketch 2. And I essentially just offset this hole by 2.5mm. And that allowed me then to make that hole just that little bit bigger. Because once I've got everything in, torqued down, tight, and so that will then give me more than enough clamping force, and that is literally just to locate this plate to those holes. So, and then once I've got bushes and Nordlock nuts, anti-vibration nuts and everything, that shouldn't be going anywhere. So yeah, the other cool thing about Fusion is that I'm worried about weight. So I can right click on him and go properties. And from here, because I've got it set to grams, it shows me my mass is 13,665.427. 13 kilos. quite happy with that. But if I want to, I can go to modify physical material, and I can change the material that's made out of something better or worse than what I am using, and that also plays into when you do structural analysis. You can, depending on whether it's made out of 304 stainless, 316 stainless, mild steel, hardened steel, cold rolled steel, that all changes how this will perform. So I can go down here to the metal tab and say I didn't really care and I want it made out of 1100 aluminium. I can select that, drag it over. Now it's made out of 1100 aluminium, and that would change its weight to 4.7 kilos. But I don't want 1100 aluminium. I'm actually getting this cut out of 304 stainless. So I'll go back to physical material. There we go. And because I last used the metal tab, so, stainless steel, yep. So you got your 316 stainless, 302, 304. That's the one I'm going to use, 304. So select him, drag him across here. And that will take me from my 12 kilos, or 13 kilos, to 13.9. So it adds a little bit of weight, which I'm happy with. So I'm just going to save that. The other cool thing you can do, this saves. I can go up here to create the flat pattern. Select the face, hit OK. Yes, activate existing flat pattern. And now what it does is it goes, okay, this is everything flattened out, and it will actually give you a DXF file up the top here. You can click on export, export as a DXF and save it, and that is the file that you can send to your laser cutter, and he will cut that, he, she, they will cut that all out of your required grade that you want, and it will be dimensionally accurate, plus or minus about 0.2 millimeters. So I've oversized all my holes by around 0.5 millimeter just to account for that. So if it comes in bigger again, that's fine. I'll be about 1 millimeter big. If they come in smaller, I've accounted for that and my holes will still be the right size. So yeah, that is the new motor mount that has been designed. Much nicer than the old mount, which hide you and bring you back up. So yeah, we have gone from this to this, which looks much better. And just for a reference, this one weighed in at 14 kilograms. So my new design is actually more dimensionally accurate and lighter, and I haven't had to have all these speed holes in it. So I'm much happier with the end result of the new one as opposed to the old one, and this should fit much nicer. Now, I'm going to get this translated onto cardboard, stack a whole heap of cardboard together because the 3D printing was nice. However, it just takes too many days to test out. So, if you like this video, please hit the like button. If you want to see more, hit subscribe. And as always, thanks for watching.